This is the second video regarding name reactions of organic chemistry, and I will be talking about Akabori Imidazole synthesis. In this video, I will discuss about literature of this reaction, reactions and mechanism. The three things will be discussed about this reaction. What are the applications of this reaction in terms of research papers where it can be published or where it has been published so far? What is the reaction? What is the mechanism? So we will start this lecture first with the definition. This reaction is about synthesis of imidazoles. Imidazoles are 5-membered 2-nitrogen containing heterocyclic compounds, and this reaction starts from esters of alpha amino acids and thiocyanate. So you need alpha amino acid and thiocyanate in order to carry out this reaction, two components. Where this has been published, I have highlighted few journals and a patent where this has been published. Australian Journal of Chemistry, this reaction has been published in this one. Journal of Organic Chemistry, Journal of Organic Chemistry, and a patent also in California State University. So what is this reaction? This reaction is about making imidazoles starting from alpha amino esters. So instead of a carboxylic acid, here we have an ester. If this was acid, we will call them amino acids. So we have to use this alpha amino ester plus potassium cyanide and a reducing agent mercury in sodium HCl and another reducing agent ferric chloride gave us the final product. The key question is how this reaction takes place, what is the mechanism of this reaction, and what are the key steps. First step is the reduction step. I have written this whole mechanism. I will show you the arrows because it's quite time taking to draw structures and speak during the lecture, and the video becomes very long. That's why I have to write the structures and then explain them, but I will show you the curly arrows in a moment. So the first step is the reduction of ester into aldehyde. So this is aldehyde and this was ester. Ester was reduced using these reagents into aldehyde. Now in the next step happens, this free lone pair of NH2 goes on to attack the carbon atom, this one, attack here on this carbon. So in that way it makes the bond with this carbon and nitrogen. This is how the first step is started, and next happens is shifting of this double bond between carbon and sulfur towards sulfur. I always confuse myself with these arrows. So this bond is shifted in favor of sulfur. So in this step, bond between this central carbon and this nitrogen is formed. That is the one. This nitrogen and this carbon bond has formed, this one, and we have a sulfur atom here as SH because it takes proton from the system. And in the next step what happens is this nitrogen attacks on the carbonyl of aldehyde, which is electrophilic center, attacks here, and then this bond shifts towards oxygen and this proton picks the proton. This oxygen picks the proton and makes it alcohol. And in the next step, this bond broken down, dehydration takes place, and the free lone pair of oxygen takes proton and leaves as a water molecule. So the water is removed, minus H2O, and an imidazole ring is formed. And in the last step, using ferric chloride, this imidazole ring is formed. So again, repeat the reaction mechanism. First step, conversion of ester into aldehyde using the reduction protocol. Reduction, this is ester converted into aldehyde, and now the nucleophilic attack, nucleophilic uptake of nitrogen on carbon. So CN bond formation takes place, which is this nitrogen and this carbon, and this S picks proton and becomes SH, this one. And in the next step, again the CN bond is formed, or a ring is closed, ring closing reaction, ring is formed here. And then in the next step, dehydration takes place, dehydration step, or removal of water to give us imidazole. And in the last step, removal of SH, removal of SH with ferric chloride. Alright, so these are the key steps. This was the reaction which we discussed in this video lecture. Hope you liked it. Please subscribe my channel for more videos. Thanks for watching.